So here in this problem, we are being provided with four sets A, B, C, and D. We need to verify that the Cartesian product of A and C is a subset of the Cartesian product of B and D. Okay, let us begin. So first what we'll do, we'll try to find out the individual Cartesian product. Let's begin by first finding out the Cartesian product between the set A and set C. Set A contains two elements, 1 and 2. We're going to find its Cartesian product with the set C, which also contains two elements, 5, 6. So what we'll have to do is take the first element of the first set, which is A. We will be using it to form an ordered pair with each of the two elements of the second set. So that's going to give us two ordered pairs. One will be 1, 5. The other is going to be 1, 6. Next, we're going to pick up the second element from this first set A and form an ordered pair with each of the two elements of 5 and 6 of the set C. So we have 2, 5 and we have 2, 6. Okay, so let's leave it aside for the time being. We are now going to obtain the Cartesian product of the set B with the set D. So B contains four elements. So we have 1, 2, 3 and 4. We're going to find out its Cartesian product with the set D, which also contains four elements, 5, 6, 7 and 8. Okay, the procedure remains the same. We have to pick up the first element of the first set, which is 1, and then form an ordered pair with each of the four elements of the second set, that is D. We're going to get 1, 5, 1, 6, we have 1, 7, and then we have 1, 8. Next, we're going to pick up the second element of the first set B and form an ordered pair with each of the four elements of the set D, the second set D. So we have 2, 5. Next, we have 2, 6. We have 2, 7. And then we have 2, 8. Next, we'll be picking up the third element from the first set and form an ordered pair with each of the four elements of the second set. We have 3, 5, 3, 6, 3, 7. And then we have 3, 8. And then finally, we're going to pick up the fourth element from the first set and form an ordered pair with each of the four elements of the second set. We have 4, 5, 4, 6, 4, 7, and then we have 4, 8. Okay. This is going to be the Cartesian product of the set B with the set D. Okay. Now, in order to verify that the Cartesian product of A and C is a subset of the Cartesian product of B and D, we have to use the definition, which is each and every element of the Cartesian product of A and C must belong to the set, the Cartesian product of B and D. So here clearly we observed that 1, 5, this belongs to the Cartesian product of A and C, implies that the same element 1, 5, we see that 1, 5 also belongs to the set B, D, the Cartesian product of B and D. We can verify for each of the elements. So we have the ordered pair 1, 6. So that is present here as well. 2, 5, that is present. 2, 6, that is present here as well. So here we can say all the elements of the set, that is the Cartesian product of A and C, belongs to, it is going to belong to the Cartesian product of the set B and D. So as all the elements of the Cartesian product of set A and C belongs to the Cartesian products of B and D, hence we can say the Cartesian product of A and C, this is going to be a subset of the set, which is the Cartesian product of B and D. Hence proved.